Alrighty guys, I'm going to show you how to do week 6. Let me share my screen real fast. Alrighty. So this is what it looks like on Moodle. So you can go ahead and click week 6. And these are the two documents that you can look at. You'll probably need to print this guy off, the second one. So this first one is basically just an explanation of slope. All right, so it can be defined as a ratio, like a 3:5 slope or a 10:12 slope. A lot of the times with architectural drafting, you'll refer to, the slope of a roof over 12, and that's basically the rise over the run. All right, and you can write that as a ratio or a fraction. All right, and then if you divide the rise over run out and then multiply it by 100, you get the percent slope. So if you are, going down the mountains and it says that there's like a 8% grade, that's how they get it. Basically, you're dropping or you're going up 8 feet for every 100 feet. So that would be 8% slope. And so usually you only use that kind of definition for, something that's not very steep. And so, you can use trig to figure out the different sides of the triangle, basically, if you have your rise and your run. And you can use these to figure out, let's say if you're out hunting and you're looking at like a topo map, a contour map, you can look at how close the contour lines are together and see exactly what slope that is, if you actually look at the scale and measure it out. So basically, these are different kinds of contour maps. All right, index contours were multiples of 5 or 10, so that would be like your major contours. Using Civil 3D, that's what they call it, your major labels. And then your intermediate would be your minor labels. So basically, that would be like every 2 feet or every 1 foot, you'd have a contour line. And there's all different kinds of contours and different denotations on what they look like in a drawing. And it also depends on who you're working for and how they like to label things. But yeah, you can interpolate or pretty much guess the slopes of things based on the distances on page of what they look like and what they measure out to be. And so yeah, you'll use this if you're a civil engineer to figure out flood zone maps, reservoir capacity estimation. If you just convert your 2D data into 3D data, you can figure out where water has been within the last 100 years, and that's usually what they call a 100-year flood mark. So usually you wouldn't really want to put your house within there, because it's likely that within 100 years you will have a flood that would flood your house if you're close to a river. So basically, this is the assignment for this week. We don't have anything in CAD per se, but I'd like you to print this guy out and make sure you have your engineer skill. So we're going to do a little bit of this slope calculation. So if you remember, Pythagorean theorem, a squared plus b squared equals c squared, you can figure out the slope. You can figure out your angular distance, horizontal distance. So if you remember earlier, we were measuring lines on the page to see what they represent. All right, so I don't have an application to use an engineer scale on screen. But let's just say when you print this sheet of paper off, from the beginning of the line to the end of the line is 2 inches, all right? And the scale says right here, 1 inch equals 200 feet, right? So if it's 2 inches long, then this line from here to there would be 400 feet, correct? So that would be your horizontal distance, all right? I'm gonna go ahead and do a snipping tool so I can, write on this. new. All right, so here's my example problem, all right? So if this guy is 400 feet, right, from here to there, because this is literally 2 inches on the page, this is 1 inch, this is 2 inches, right? Oh, that was a terrible 2. Yeah, 2 inches, 1 inch is 2 equals. Okay, so that would be 4 inches, and that would be this horizontal distance because you're looking on the page, top down. So this would be 400 feet, all right? That would be your horizontal distance. What this number here represents is the actual elevation, okay? So you can subtract the 2 and figure out what your A value would be, or your change in elevation, all right? So let's go find the calculator. All right. So you have 5146 and 52408. All right. So 5208 minus 5146. All right. So that's your change in elevation is 62 feet. Okay. So that's what this A is going to be. All right. 62 feet. Okay. The horizontal distance between the 2 points, we already figured that out. It's 400. 400 feet. And this is your rise. So calculate the slope. So it's rise over run. So 62 over 400. You can literally just type that in the calculator. So 62 divided by 400.155. So then you multiply it by 100 to actually get your percent. So times 100, or you just move the decimal over. 15.5% slope. All right. So that would be the answer for B right there. Round to the nearest 10%. So yeah, 15.5% slope. All right. Now it's asking what's the angular distance between the 2 points? Or in other words, what is the hypotenuse of this triangle? Okay. So A squared plus B squared equals C squared. So what you can do is do the square root of A squared plus B squared equals C. Because you're basically undoing the C squared, bringing it over here. So 62 squared plus 400 squared. And then it's the square root of all that equals C, or our hypotenuse, our angular distance. So what's 62 squared? 62 times 62, 3844. All right. So 3844. 400 squared is 16,000, I believe. So 400 times 400. Oh, 160,000 actually. Yeah. So plus 160,000. All right. And the square root of all that when you add it together. So let's take 160,000 plus 3844. 163844. All right, I'm just going to write that down. So what is the square root of 16384? Oops. 44, and that would be C. So the square root is 404.776. So that would be C equals 404.77 feet. And it says round to the nearest foot. So it'd really be 405 feet. And the last thing you do is just, look at your triangle. Does that make sense? Yes, it does, because it's not much difference between B because our elevation change is relatively small. So 405. That would be our answer for C. All right. So another thing that is important to note is that I want you to show if the slope is a positive or a negative slope, all right? So if this first number, well, looking at this one, this first number is lower than the second number. So that means that this line would be increasing, right? So this would be a positive slope. Some of the questions have the first number greater than the second number, which would mean that from here to there, that, you know, it's going down in elevation, which means that our slope would be negative. So just be careful with that on the letter B of these questions to make sure you know if it's a positive slope or a negative slope based on, you know, which one's a bigger number. Alrighty. So that's, you know, the example of how to do this assignment, the first part anyways. And this last part here, basically these are a representation of what it would look like in AutoCAD if you have a bunch of survey points, okay? So these different numbers are different elevations. So we know that contour lines connect points of equal elevation, okay? So basically I just want you to guess or interpolate what contour lines would look like using these elevation points, okay? So I'm gonna go back to my snipping tool so I can draw. Alrighty. So these are the elevations, right? Points of equal elevation would connect. So let's start over here. So 4190, these ones would connect, all right? There's one contour line. 4200, 4200, it would look something like this. I mean, it doesn't really have to be perfect because we're literally just guessing what it would look like. And when you throw it into AutoCAD, that's exactly what the computer does too. It just connects the dots using triangles to create a surface that, you know, represents the shape of the surface of the Earth. And if you had more points in a closed area, the more accurate your surface will be, right? If you were to go out and use LiDAR, you would literally scan the surface of the Earth. You'd have billions of points and it would be very accurate. But realistically, you probably just use your total station out there surveying and you'd have fewer points, but you don't really need that many points because you're going to change the surface of the Earth anyways, right? So I just want you to kind of draw your own contour lines, what you think these guys would look like, right? So right here, 4160 looks like the lowest point here, okay, on this side. So I'm gonna, 4150 actually. So I'm going to connect these 4160s together. So that would be like, you know, the bottom of a valley would be the lowest point right there, 4150, all right? And these ones would connect 4170, 4170, and it looks like I missed one here on 4160, so it would actually go something like this. All right? And I basically just want you to, you know, fill out the rest, make sure there's a line going through every point and that they are connecting, all right? So we got a low point here, over here, looks like we have a high point, 4260. All right, so that would be our high point, 4240. This would be our low point over here, or yeah, a little bit lower. It looks something like that. But yeah, you get the idea, right? This is what, you know, your contour map would look like, okay? So you can go ahead and fill out the rest, how you think that these lines would be. Not really a wrong answer as long as you try, you know, your best, because that's literally all we're doing is guessing. And that's all the computer does is guess. We'll find out later how you can modify your surface to correct for errors that could possibly show up in the computer's guessing to try to correct the contour lines, all right? And that's pretty much all I had for week 6. So if that's helpful, hopefully it is. If you have any questions, let me know. And thank you.